signal we have plotted. And the different, I told you the different carrier signals we are going to use, right? So the different signals are going to be, it is called as raised cosine pulse. This is going to be the different raised cosine pulses for the different amplitude. So here we have taken alpha as 0.5. So 0.5 and all what means? It will say how much the signal has to be sharply falling off. See, always it's a cosine pulse. So 0, when you put t is equal to 0, you will get a maximum. The maximum value you will get. And from the maximum value, how fast it is falling off. That is called as the roll-off factor. So see here, alpha is a roll-off factor, and then predominantly we'll take alpha value to be 0.5. So when you have a raised cosine pulse, when alpha is equal to 0, it is looking like a sync pulse. So you get a rectangular signal as the frequency domain spectrum. When alpha value is going to change from 0 to 1, accordingly, the signal will also going to change. So this is the time domain, this is the frequency domain. You should have studied about the Nyquist criteria and all, right? So that is all based on this only. So in Nyquist criteria, we'll be using raised cosine pulse for transmitting as well as reception. That is what I'm doing. So see here, I'm generating a raised cosine pulse and I'm using it for transmission. Receiver also, I'm doing the same convolution using the same pulse to get back my original signal. Two things you have to know. One is I'm doing PAM here. PAM is pulse amplitude modulation, and I'm measuring the effectiveness of my channel using the eye diagram. An eye diagram will clearly say the channel is fit or not for transmission based on the eye opening. If the eye opening is very good, the eye opening is very broad, it means that the channel is having less affected. The channel is less affected by noise. Assume that I will change the number of symbols to 100 to 1000. So by having more symbols, we'll see whether it is affecting my eye diagram or not. The lines are becoming darker because more symbols are getting transmitted. Okay, the more symbols are getting transmitted. Maybe if I make it 10,000, it will still become even more dark. It will take some time because I'm having 10,000 symbols, so it will take some time for compiling. Let's be patient with that. You will be getting a dark eye diagram, and the eye opening is remaining same because the channel is not affected by noise. That's the beauty of raised cosine pulse. So raised cosine pulse you are going to use means be less affected by noise. Maybe I'm going to stop it because it is taking a longer time. I'm changing back to 100 and see here alpha. So assume if you give alpha value as 0, we'll see what is the impact. If alpha value is 0, what is the impact? Now you see the eye diagram. It is, what is the eye opening here? 0.5. The lowest point here is 0.5. Here it is 0.5. So the eye opening is 1. It is reduced. The eye opening has reduced C, which means channel is noisy. If I give alpha is equal to 1, the conditions we have seen, right? Alpha is equal to 0. See the previous diagram. Alpha is equal to 0. Alpha is equal to 0.5. Alpha is equal to 1. So for alpha is equal to 0.5, the eye opening was very good. When alpha is equal to 0, we got the eye opening to be poor. When alpha is equal to 1, see the eye opening is very good. So generally, you have to have the alpha value between 0.5 and 1. That is for proper reception of your signal. That is the conclusion. Okay, and lot of other parameters can be derived from eye diagram or eye pattern. I request you to read the corresponding theory textbooks for the other parameters. Okay.